Well, today we are dealing with low-slope roofing systems. So here we're looking at a single-ply roofing material. And down here we're dealing with hot mop, or a built-up roof. And so that's an abbreviation you're going to want to learn. It's called BUR, an abbreviation, stands for built-up roof. But it deals basically with what we sometimes call a tar and gravel roof, but it's really not tar, it's asphalt. Hot asphalt mopped into layers of paper, roofing felt. So yeah, we'll deal with fall protection a little bit, roof decks themselves, the insulation and vapor retarders that we use, rigid insulation that is used on top of roofs sometimes, vapor retarders for low slope roofs in general, and various other membranes. And then there's ballasting. Ballasts can be made of gravel or concrete that are put on top of roofs in order to weigh them down and to protect them from ultraviolet rays. And then, of course, if you're putting concrete pavers down on top of roofing for traffic, if people are actually going to walk on a roof. The edge and draining. And then ultimately, one of the best materials for cost effectiveness anyways would be structural steel panel roofing materials. So we'll look at those. So here's some of the things about safety, but safety, we have another class for that, so we won't spend a lot of time, but just understand that even though it's a nice flat roof, easy to walk around on, you can easily accidentally slip off or step off the roof if you're not paying attention, so you still have to think about fall protection. So what is a low slope roof compared to a steep slope roof? We'll deal with steep slope roofs after this section, but so we go by a roof slope. So a roof slope that's a low slope would be a 212 slope or less. So what do we mean by that? Well, for every 2 inches that we go vertically, we go over horizontally 12 inches. Well, the horizontal number is always 12 inches. We have to choose which roofing material depending on what the slope is. You can't use shingles on a low slope roof. And generally, we don't use membranes, solid membranes, too much on steeper slope roofs. So there's this crossover period or crossover zone where sometimes people try to use shingles on lower slope roofs, and without much success. It's problematic. And sometimes they try to use membranes where they probably should use shingles or tiles or slate panels and that sort of thing. So a flat roof is a misnomer. There's very few roofs that are truly flat and level. They always have some sort of a slope. So that means generally minimum of a 1/4 inch per foot slope just to send the water somewhere. And so when you're looking at a 112 slope, well, that's 1 inch per foot. So that would be a reasonable thing. There are some roofs where they can get away with as little as a 1/4 inch per foot slope. Probably one of the most successful choices there might be a sheet metal roof if it's rigid enough steel, because even walking on a sheet metal roof could damage it enough to create puddles, and so unless it's thick enough gauge of metal. So, and then roofing manufacturers typically have a minimum slope requirement, and they will specify that on the roofing specifications to honor their product warranties. For instance, shingles made of asphalt fiberglass material, the typical shingles we use, what we call a composition roof, roofing shingle, will list on the bag of shingles 412 slope minimum to honor a warranty. So the building codes allow you to go down to as little as a 2.5 12 slope. That means 2.5 inches up for every 12 inches horizontal. And so how does that square away with your warranty? It doesn't really. What happens is that on the building code, they will require you to double up the underlayment and cut the reveal of the shingle down so that you have less shingle revealed. So that means you have to have more overlap. That takes more shingles. So what they do is they cheat on both ends, and they get a kind of a mediocre result. typically with shingle roofs on anything less than a 412 slope, you do have leakage. Unless you just put in a good solid single-ply roofing down as your really, really good membrane for your underlayment, which is not really cost-effective to do it that way. And then you end up putting the shingles on top for decoration, but you're really relying on the roofing membrane underneath. So this picture is showing you kind of what the slopes would look like, the profile of the slopes of roofs on a 112, 212, 312. Until you get to 412, you really shouldn't be using shingles because the water will back up underneath the shingles. So you get the idea. So anything technically from a 212, greater than a 212 slope is considered a steep slope roof. But really and truly, I would say that definition should be changed to 412 as being a minimum. That said, as far as a test question goes, we're going to stick with anything steeper than 212. So the first two roofs you see on this little blue picture here are considered in the low slope category. And then, of course, you can get so steep that some of these roofs are so steep that they'll clean the roofers off the roof too. So here we're looking at a graph that kind of shows that the low slope region is from 212 down to about quarter 12, a quarter inch per up for every 12 inches horizontally. So then there's another thing we should shy away from is you got to be very careful and beware of anybody who starts talking about roof pitch, because it's a nebulous, confusing concept. If you look at these roofs back here, the pitch, you take the overall rise divided by the overall span of the building. And that is really a meaningless number. I mean, in comparison, one slope to another, they can have some meaning, but it's a lot of people, when they say roof pitch, they really mean roof slope. So you just be very careful when somebody starts talking about the pitch of a roof, because it's a meaningless number by itself, unless you define those numbers and those terms. And many people, and textbooks even, get it wrong. And so just be very careful. Roof slope is a much more reliable definition to deal with, and it has real mathematical value. So, okay, so let's see. When you're looking at these slopes, well, maybe another thing to point out on that back on that other page is that when you're looking at these roof slopes, you know, the shortest distance between 2 points is a straight line. And so a 112 slope is getting to be a fairly straight line, and a 212 is not much different. So I guess what I'm trying to say, as you go to steeper and steeper roofs, you're using more roofing material. So your cost of roofing generally go up as you go for steeper and steeper roofs, because you need more roofing material. So that's another thing just to point out. But, you know, in a heavy rain zone like Louisiana, where we can get very heavy rain all at once, a steep roof can be a good thing from that standpoint. The water's not hanging around long enough to leak. I've seen roofs that have steep roofs with a bullet hole in them, and they're not leaking because the water's running down the roof so fast. So there is pros and cons. If you have a high wind, straight line winds, the steep roof takes a beating, whereas a low slope roof, the high winds fluting across the top can literally suck the roofing materials off the roof. So there's different issues to worry about with high wind with steep roofs compared to the low slope roofs. Okay, so that's enough about that, and enough about this picture. So this picture is showing you similar text on it, but it's showing you a built-up roof with the tar and gravel roof. I still call it a tar and gravel roof sometimes, but it's really asphalt, melted asphalt in layers of paper, and then they put the gravel on top as a ballast, and it helps to protect it from the ultraviolet rays deteriorating the tar and materials on the roof. So it's more of it weighs the roof down to keep it from being sucked off the roof in a high wind, because you get this negative pressure across the top of the roof when the wind's blowing. But so the ballast is there to protect against UV rays and for wind suction, sucking that roof material off the building. So you have to start off with a roof deck. And so if you've got plywood as your roof deck, well, it's flammable. And so if it's a commercial roof, you're going to have to protect it with fireproof material. So then they go and put down a fireproof material like a drywall. And you say, drywall on the outside of a building? Well, we do it all the time. You saw that in chapter 11 when we were dealing with the sheet metal or the structure on the outside of a building. And we saw it in chapter 12 with the outside of a building when we're putting metal framing studs on the outside. We'll put sheet metal, we'll put drywall sheets that are meant for outdoors and an exterior grade sheathing of drywall, gypsum board, you know. Here we're looking at structural steel building, structural steel frame, corrugated steel decking on each floor, and then up at the top on the roof. And they'll typically pour concrete. Maybe on the roof they might use a lightweight concrete. And then they can put their roofing membrane down on top of that. Or there's other patterns. You can have the decking could have an insulation put down first and then the roofing membrane. There's a couple of patterns in here. So the roof deck has to be strong enough to take the loads. And on a roof, a lot of times the load is actually the possible ponding of water. So if you end up with a clogged drain, you could end up with quite the pool of water on top of the building, which if you don't design for it to make the building strong enough, then the whole roof structure could collapse, and that could cause the whole building to collapse. So we have to make the thing strong enough to deal with that, and it means there's typically on a low slope roof, a flat roof, where there's drains involved that could possibly clog. That means there's typically maintenance that has to go on. If we often find abandoned buildings where no one's taking care of that eventually collapse because leaves blow up there. It's amazing. I've seen leaves get up on 10, 12-story buildings and clog drains. And so it can get on the roof of lower buildings very easily. They just blow around, they end up collecting and then eventually building up around the drains. And we can have a strainer around that, and that helps some. It helps a lot, but it's not permanent. Eventually enough leaves clogging up there will cause a big pond of water up there, and then eventually at least find the leaks where they can drain into and start causing water damage. But oftentimes heavy enough rain that we can get around here, the drains can't keep up with all those leaves on top and they can collapse the building. So the roof has to have some kind of slope. You can either slope the structure. Sometimes with a flat roof, they'll literally have a flat truss that goes from one wall to the other, where one wall has been made shorter than the other so that you get a natural slope, and they can either let it pour off the edge of the roof, maybe on the back side of the building, maybe, or they could pour off into gutters, or they could collect into slope towards drains and stuff. So you can have a slope structure, a tapered structure, or sometimes the thickness of the insulation can be, you can buy tapered insulation and they literally slope it somewhere that way. And so there's different techniques that are used, but you've got to slope the water to send it somewhere. You got to slope that roofing material one way or the other in order to send the water somewhere. You can't just have a flat sheet that's perfectly level and expect the water to drain away like you need it to. So here's some of that gypsum substrate, they're calling it here, which is basically a exterior grade drywall they're putting down on top of the plywood. And they're nailing it down with some big flat washers and nails. Sometimes they've got special guns that can shoot that and distribute the disc and the nail. Or sometimes it's done manually with a good old-fashioned little stubby nail that's just long enough to go through the drywall and into the plywood. So there's three basic ways that we place the insulation. You got to have insulation on your roofing system, almost always. If it's a building, you do. And so you can either have the insulation below the deck, which is what you see in this picture, and that could often be fiberglass batting insulation, traditional kind of insulation. It could be friction fit between the joists like this. And if you have something like that, you've got to vent each bay in between each pair of joists, because otherwise moisture will condense. If you've got an airspace above the insulation, you have to vent each one of those bays. And if you're not doing that, then you'll have condensation and stains in your ceilings from this and possibly decay, attracting termites and mold and that sort of thing. Now, if you've got fiberglass batting, you've got a space up there whether you like it or not, because it's not a solid enough material. But if you use spray foam, then you can fill the space and venting is not necessary then. So when you use spray foam up there, then there is no airspace. So the first case is what we're looking at, insulation below the deck. And that's the old-fashioned technique, and there's plenty of modern new buildings done this same way. But that's when you can see the insulation up on the deck in any fashion, unless it's spray foam, then you've got to ventilate in between each of those areas. That means you got to have a vented attic no matter what. Okay, so this is showing a picture of what you might expect. You'd see fiberglass batting that's friction fit up there. It means that if you're not venting each one of those cavities, you're going to have trouble. Now, this is showing a diagram, but it's showing spray foam, air impermeable air foam insulation. So that's the closed cell spray foam that you've probably seen lots of. And I think I got a picture of that. Oh, no, somewhere I do. Okay. Well, we'll get to that. So now the next category is having the insulation above the deck, above the roof decking. So there's two kinds there. This case 2 is insulation between the deck and the membrane. So that's a pretty common, we call this an inverted roof. We literally flip the formula and we put the insulation on top of the roof deck. And then we put the roofing membrane on top of the insulation. And this is the typical model we do. If we're going to slope by having different thicknesses of insulation, that means you're going to have the roofing membrane on top of the insulation. Most common configuration for a it's called an inverted roof, where you have and this is more common than anything else as far as modern roof decks on the commercial buildings. You see it a lot. And then they see there's a little squiggly stuff they're showing up top. Well, they got the membrane down there, but then they put the gravel. They still put gravel down on top of all of that to protect the roofing material because it's exposed otherwise. Okay, so that's case number 2. Case number 2, these are just pictures mostly of problems. So the hot mop roof, or the built-up roof I was pointing out earlier, is the cheapest roofing material, and that's basically kind of what well, it's not really exactly what we're looking at in this picture on top. And then you're seeing a single-ply plastic material that's used as a membrane. It's a very, very common roofing material, a single-ply material, and down at the bottom, and that has those domes. And so oftentimes the problem with this inverted roof is you can have enough space in there where moisture can still get in, and if it can, it's going to get very hot, and it can create these little blisters. So if you're ever walking on a roof, be careful about flaws like what you see up top here, where my cursor is squiggling around, or down here where you see these domes. They're blisters, both of them. And you walk on those things and you can break up that roofing. And so next thing you know, just having gone up to inspect a roof, look around, you step on some of those things and collapse them a little bit, you've created roof leaks. And next thing you know, you break it, you bought it. So be very careful when you go to inspect a roof or look up on an old roof for whatever reason where you walk. You also should not walk anywhere near these edges because the roofing is generally not glued down in this spot. It's going to be under tension and maybe loose, but it can be changed depending on the time of year and the temperature. And so the idea that to keep it from cracking along this area, they give you they don't glue it down, so there can be some more flexibility to keep it from tearing itself up as there's movement on the roof. And so to get rid of those blisters, they sometimes vent between the roofing membrane and the insulation in order to vent up some of that steam from any moisture that manages to get in there. Here's some of the tapered insulation that could be used. Can't really tell how well it's tapered, but they'll have different thicknesses at the very least in order to send the water toward a drain. And then the third category of the 3 is insulation above the roof membrane. It's a roof membrane, sorry. Roof brain? Yeah, no. Insulation above the roof membrane. And so that means that the roofing membrane goes down on top of the roof deck, which means the roof deck had to be sloped to begin with because you won't have any other technique to deal with that. And then they put the insulation on top of that. They usually have some structure to lift it up off the roof membrane so that there's a cavity underneath, and then the insulation is there. And then they put the gravel on top of the insulation to keep it from blowing away and keep it from deteriorating in the sun. So either way, the ultraviolet rays of the sun, the gravel is there to protect it, and it's ballast. Ballast means that it's weighing it down. In truth, when we have shingles with the asphalt fiberglass shingles that we use on most of our houses, they have a sandy material on them, and that's called ballast also. Okay, so called a protected roof membrane, PMR sometimes. Okay, I'm not going to make you memorize that abbreviation or anything, but anyways, that's the other model. So here's an example where actually this is not the third case. This is the second case where they've got the insulation they've got some kind of plastic members that are turned in to kind of give you a friction grab at each corner of these chunks of insulation to hold them down, and then they're putting a gypsum substrate material down on top of that, and then the membrane goes up on top of that. So problem with fiberglass, the problem with foam insulation is it burns like crazy. It's not fireproof at all. And so that big chunky material you see there is a polystyrene insulation. It's going to burn like gasoline. And so you had to protect it with the gypsum fireproofing drywall material. And so that goes on top of that, and then the roofing membrane. Here we're looking at concrete. So lightweight concrete probably. And it can be put down on top of the insulation also. And then the lightweight concrete has an R value too. It's relatively low, but it still can enhance whatever else is going on with the foam insulation. And it's a fireproof material. So it can be as light as 7 times lighter than conventional concrete in some cases. But if you're going to have traffic on there, it would probably have to be more of a medium weight concrete in order to be strong enough. It will take the traffic without breaking up from the flexing. Here's some more of that gypsum. It looks like there's 2 layers of gypsum substrate. So you might have one down and been told that you need to go with more than that. And so then you add another layer and you change the pattern. So when we talk about a roofing membrane, any kind of a roofing material, it is more than a vapor retarder. It truly is a vapor barrier because you need it to be so leak-proof that water's not going to migrate through it at all. And so it's a higher degree of vapor retarder. You can call it a vapor retarder, but it's going to be a very high-quality vapor retarder, let's put it that way. So now we're finally to a case where I'm going to look at the different low-slope roofing systems we have here. There's 3 categories, basically. The bituminous category, that you see, that first one. And then the second one group is single-ply material, of various kinds of plastic materials. And then there's the fluid applied, or spray applied. So fluid applied. So we'll look at the bituminous category first. You see how there's the built-up roof that I've been talking about, that model. And it can be asphalt or coal tar, but the vast majority of it is not coal tar. It's going to be asphalt. And then there's mod bit, or modified bitumen roof. And so that stuff is rolled down and flamed into place, melted with a big torch onto the roof deck. Whereas this other stuff starts off hot from a big kettle that's heating up the asphalt, and then you mop it around before it cools off. Okay, so let's look at that category first. The built-up roof, it's sometimes called a hot mop roof because they often are mopping this hot material. And by hot, I mean maybe 300, 350 degrees. So you don't want that on your skin. So you see these 2 guys, it might be hot out there, especially working around this stuff. They're not in shorts and a t-shirt. You're going to have clothing on, long sleeves, and gloves to protect your skin from burn. Any amount on your skin is going to be a serious burn. So they literally spread this stuff up in a team. It usually takes a team of 2 or 3 people and maybe somebody on the ground that's heating this stuff up and pumping it or bucketing the stuff up to the roof where it's mopped around through the layers of paper. And so they use a similar material to the roofing felt material that we use as underlayments, as an old-fashioned material to be used on roofs for shingles. And so the built-up roof, or BUR roof, depending on the spacing of the plies, could be 2, 3, 4, maybe up to even 5 or 7 sometimes. But of course, the cost goes up when you have more plies. And so plenty of roofs up there that are 3, 6, 7 plies, but a lot of 3 plies out there, I think. Okay, and so then they end up and most of them, they put a pea gravel down. It's basically like about the size of peas in little gravel form that are spread out on top of all that stuff after it cools off, and it basically weighs the roofing down, like I said. So sometimes it's a crushed rock, sometimes it's more of a rounder rock. The problem with crushed rock is that as you walk on it, you could be damaging the roofing material a little bit, so it's actually better if it's a round rock. But many cases they don't have that available, and so they end up with a crushed rock. And you could have a liquid coating put down on top of it that's a reflective coating, like you see here. Usually aluminum particles within the asphalt emulsion applied over top of the built-up roof. So that's another way to get the ultraviolet protection. And you get a reflective shiny surface which can reflect the heat away somewhat, so that can be useful. Now on the mod bit form, it's a similar material. You're talking about asphalt being melted down to the roof, but it's already embedded in a roll of material. So the best thing is for me to show you a picture of it. So here they've literally got a roofing paper or material, membrane, that has asphalt embedded on it. So then they're heating the asphalt with that big old torch and rolling that roll out. And so it takes less material, less equipment, let's put it that way, to put this stuff down, but it's more expensive. And it's not necessarily better, it's just the contractors can like it because they can put it down, and it's still going to be cheaper than other roofing membranes you're going to put down. The problem is buildings have been known to burn down from this. Wonder why? Look at all those flames. So you get an old house, and if you get any kind of a amount of flame that gets into the inside of the building from this process, you could have a smoldering going on inside the attic that burns the house down overnight, or the building down, sort of thing. So torch down roofing is outlawed in some cities because they've had blocks of buildings burning down because of this. And it comes when everybody's asleep in the middle of the night, so it can be dangerous and kill people. So it's dangerous in several ways. So the mod bit roof, sometimes just called torch down roofing, has a factory applied adhesive, but it's generally made of asphalt, and you're heating up the asphalt with the torch. Here's another version of that, maybe a little fancier one with a bright white surface on the top side, which, a lighter surface will reflect some of the heat from the sun back out, so it can be useful. And it can take more ultraviolet rays without deteriorating the roofing material. So there's that. And so now we're looking at single-ply materials. So in modern buildings, when they've got the money for it, they're going to likely want to pick this kind of roofing material. A single-ply material will last longer than those asphalt roofs we were just looking at with the built-up roofs. These don't last as long. You're lucky if you get 10 years out of a bituminous roofing material like this. The single-plies, they can last twice that long. So there's 2 categories. There's the thermoset column you see at the top there of that graphic, and there's the thermoplastic. So the difference between them is that the thermoset, you're using entirely glue and nails. So you put nails down, and then the next layer goes on top and hides the nails, but you glue those things down. You glue the sheets of plastic down. There's EPDM. You see that as the first category, which is a horrible abbreviation, but it doesn't seem so horrible once you see what it stands for. It's easier to remember EPDM than it is ethylene propylene diene monomer. Yes, indeed. And then there's some other categories, but by far the most common of the thermoset is the EPDM. And so that's one that you need to know. EPDM, and remember that EPDM is that thermoset. Now, if you think about glue sets up, and so that's what we're doing. We're gluing this stuff down. So it's called thermoset, and the word set is in the concept of gluing the seams down and everything. So that's glued down. Okay. Then the other category is thermoplastic. And the thermoplastic can also be glued down in some places, but the seams are generally welded. You see that down at the bottom. And we're not talking about arc welding. We're talking about a heat gun that we're heating the seams up to melt the two layers together. So it's melted together with a heat gun, basically. So it's better for me to show you some pictures. So yeah, the single-ply material, they come in all kinds of bright, pretty colors, and that helps to reflect heat away. Remember that a low-slope roof is not often viewable from the street. And so when you're looking at a building, you don't see the roofing material at all. And so it doesn't matter if it was polka dotted, nobody would see it. The only place you can see it from typically is from above, maybe from a taller building next door or something. So a lot of times these colors aren't so important for aesthetics as they are for reflecting light and heat. Keeping a cooler roof can save energy. Okay, and so here they're putting a membrane down. It looks to me like, well, it's hard to say at this point because they can be put down the same way where you use fasteners on the top of the lower sheet. So the idea, just like shingles, you've got to install the lower sheets of membrane first. So with the shingles, you start at the bottom of the roof and you work your way up, laying shingles on top of shingles. Well, the same thing is true with these gentle slopes here, is you can't start at the top of the roof and work down because then you'd be lapping the wrong way. You need to start at the bottom, and as you work higher, that's what we're looking at. It'd be lower roof would be on the right-hand side of the page. When we're looking here, we're at the left-hand side, we're at a slightly higher elevation. It's not that you can really tell other than the fact that, we have to lap them in the same way we do shingles so that the water will roll off of one sheet and onto the next sheet. So if there's any flaws in the seam, that you're still managing to keep the water rolling from sheet to sheet down the roof. So they're putting fasteners down first. The thing that changes whether you're talking about thermoset or thermoplastic material is what you do next, whether you're gluing it down or whether you're using a heat gun to fuse it down. So we'll kind of skip over here and look first of all at the thermoplastic materials. Well, I've mentioned EPDM, so I guess it's not first of all, but the thermoplastic materials, the two most common ones are the PVC and the TPO. So the PVC is a fancy name for, polyvinyl chloride, which is another, it's vinyl. So when we talk about vinyl windows, we talk about vinyl anything, it's polyvinyl chloride material. And this is a membrane we often use for shower linings too. So it's, it's used for a lot of purposes. But in this form, they'll have pretty colors or whatever they'll have, and you're basically going to be fusing it down with a heat gun. And it might be glued in some places, but it's going to be at the seams. We would be joining those seams by melting the two together. And if you get it right, it's a very durable surface that you've done with that seam. Then anyways, PVC or TPO. TPO for thermoplastic polyolefin. Yeah, I have a harder time pronouncing that one. But anyways, TPO is easier. So when I said heat gun, you can kind of see a heat gun in that mess of that mechanism. It's a weighted thing that they're rolling back and forth across the seam, and meanwhile it's actually got a little pointed, slotted thing that goes between the layers so they can heat the materials between the sheets. And they roll it along and they melt the surfaces together. So that's how it's normally done. Whereas the EPDM material, it's a synthetic rubber. Well, most of these are synthetic rubbers of some kind, but EPDM is always considered to be a synthetic rubber under any category. It's highly resistant to degrading effects of heat, and it seems to do very well with the ultraviolet radiation. And that's an important function here because we don't put any ballast down typically on these thermoset or thermoplastic materials. It's just the material itself. So in thermoset materials, here it's kind of an old-fashioned technique. They're actually taping the joints down after they put the glue in place. I don't see that happening anymore. What happens nowadays with the glue is they put the glue down, they roll it out. I mean, they have a weighted roller, kind of like we had in the other picture, but then you stick it down, you pull it up and wait and count to 30 seconds or something like that, let it air out some, and then you stick it back down and it tacks down on its own. And as long as nobody steps on it, they will keep away from it for a period of time. It tends to set up fairly quickly. So the glues have gotten better. I guess that's what's happened. But anyway, so it's a pretty easy material to work with if you got some practice. So the labor is not anywhere near as much for these kinds of materials, these thermoset and thermoplastic materials. It seems like they fart around a lot with the thermoplastic heat gun, I think, getting it right. But if you got the right equipment, this stuff can be much faster than the bituminous materials we started off dealing with. So a lot of the higher end brand new buildings are going to go with some material like this on a roof because they want it to last a long enough time for nobody to be mean or sad and angry and all that kind of stuff. Okay, you want to keep the customers happy. And then there's the fluid applied, the last category. The fluid applied materials are literally sprayed with a gun or sometimes poured out in a bucket and mopped around, with a mop or a squeegee or whatever to spread it around. But I say that many cases they're putting it on top of. They often put it down on a old roof in order to add some more miles to that roof. So it's often used as a repair to an old roof. It's kind of like a rhino lining that you put in the back of a pickup truck, but for roofs. But also, this stuff a lot of these mixtures, the neoprene, I think I'm not sure about the silicone, but the polyurethane also I know can be put down in the rain. So you could literally be in a pouring rain and you got a roof leak and you get a guy out there on that roof and he's spraying and fighting the storm and fixing your leak in the middle of the rainstorm. I mean, that's not the best way to put it down, but it can be done that way. So it's an emergency material a lot of times so they get paid big bucks to put this stuff down because people are desperate to save the building from the water damage, So that's where they really shine with the fluid applied. But this looks like a brand new building being put down with fluid applied material here. So nifty stuff. The guy's boots get coated. You see his boots are white today. If he's putting down a different color tomorrow, his boots will be a different color. Okay. And then the structural panel metal roofing, well, sheet metal roofing, basically, is a material that crosses boundaries. It's really the only material I've ever been able to think about that works this way, where you can use the sheet metal for a low slope roof, and it's also a roofing material that can be used for a steep roof. So steep roofs and low slope roofs, this is a material that can work for both. And what really makes it economical is that it can also be the roof deck. So it's the roofing material that is also the roof deck. You can put this stuff down as a roof deck material all by itself. And so it's the decking and the roofing material. The big problem with sheet metal roofs is if the wind can catch a corner of it anywhere, it can take it off and peel that whole roof material off, and that can be a disaster. Also, when you've got big metal shops, big structural steel warehouses and stuff, they'll often put this stuff down for that. It's a common material to use, and you can put up these buildings quick and get a roof on it quick and be in business quickly. If a garage door is left open, or if the garage door isn't strong enough to withstand the wind blowing against the side of the building, it can blow in that garage door, and then it inflates the building and takes that whole roof off really easily. So those are problems with windstorms, and then problems if it's not installed well at the edges so that the wind cannot catch it is what you need to worry about, making sure. But this stuff can generally be kept down to as low as a 1/4 inch per foot slope. So when we start looking at really gentle slopes like that, the sheet metal roof is a good candidate for that. Okay, so here's an example where they've got standing seams, and they've literally got a collar here that they're putting down to reduce the thermal bridging, because one of the problems with this sheet metal roof is that the heat migrates right through it, so it tends to bridge the temperature right through it. So to combat the temperature, we have a thermal break by having a collar like this, so that the roofing is sitting on these little insulators instead of conducting through the steel joist or open web steel joist or whatever it is down below. So EPDM is a huge popular roof, and I would bet this is an older graphic, so I wouldn't be surprised that EPDM has taken over more of the bituminous roofing material. I think there's only companies that put down bituminous roofs. They kind of specialize, especially with the built-up roof, because you need the kiln and you got to have the team that knows what they're doing. So there's really only a handful, probably in Baton Rouge, of companies that are really set up to do that kind of material, and they stay busy, I'm sure. But the features and the cost coming down for the single-ply roofing materials, whether they be EPDM in the thermal set side or PVC TPO on the thermoplastic side, they're competing, and they're taking more market share all the time, and they last longer. Okay, we have to slope the roofs towards drains, or you let it roll off the side of a roof. And so if you are sloping towards drains, we often will end up with sections of roof where we artificially raise the roof back up in order to send it toward a drain. And if they're structures that we're building, we call them crickets. So this picture is looking down on plan view from above, so it's not the best thing. But we also use crickets to slope and divert water on steep slope roofs. So it'd be better for me to show you a cricket picture in there when we get to the next half. With this chapter 16, I've divided it into 16A on low slope roofs. That's what we're dealing with today. And then steep slope roofs will be 16B. So from there, here, if you got the water rolling off the edge, then you might have a gutter that collects. In this case, I think it's an isolated drain at the edge of the roof. And so you'd be sending the water all the way over to a periodic drains like this. So again, remember the BUR up that first bullet stands for built up roof, and that's the asphalt and gravel roof. Also notice that at the edge of the roof, you could have a sheet metal edge or you could have a solid wood edge, but it typically runs at a 45-degree angle in the transition of the roofing material rather than a sharp 90-degree angle. You wrap the material up the edge, and you don't want it glued in this section. You want it glued up top and glued down the bottom, but not in the 45-degree angle section, so that you can have the expansion and contraction of the material, thermal expansion and contraction, without tearing up the roofing material. It's a very problematic area on a roof, and so the details have to be dealt with there one way or the other to transition the roofing material as it wraps up the wall or wraps up some curb if they've got it here. But a lot of times we'll have a firewall or a false edge that goes up, could go up 3 feet in the air even, and transitioning up that wall, the roofing material will be, you'll have what we call a cant strip. And so I'll find a picture of that cant strip somewhere here in a minute. Okay, right here. So here we've got a parapet wall sticking up, and you've got, sometimes they take a 4x4 post or a 3x3 post, and they rip it at a 45-degree angle all the way along the whole length of it, so they end up with this triangular strip that goes in there, and the roofing material is transitioning up the edge of that roof. And then they'll have counter flashing that goes over top of it so that water can't dribble down and get past it. So they'll run that in that. Some of these details are very, very, very important. And then I mentioned the drains, and so the drains will typically have a strainer that keeps stuff from falling in. I remember I had a maintenance contract on a building downtown Baton Rouge, and it was a 4-story building being used by the state, and the owner had me go and check out things. He'd contact me at certain times when there'd be problems, basically, on this thing. And one of them, they had some kind of a water leak going on, but it turned out the problem was that even though it's 4 stories up, there was some rubber balls up on that roof that had gotten there, I guess, because kids were bouncing balls against the side of the building, and some of them were accidentally getting up on the roof. And one of them had made a pretty nice cork to clog that. There was a strainer missing, and the rubber ball was literally corking the drain and causing a whole bunch of water on that roof. And so it's a good thing I went when I did, pull that thing and drain that out. And so, because it finds when you have a pool of water, a lot of these roofs aren't going to be good enough to be able to keep back like a pool liner would, to keep the water from finding its way through some flaws somewhere along the way in the roofing material. So it's important to keep these strainers clear, but also make sure you really have strainers up there and not anything missing over time. This roof building was ancient, so who knows what reason they were missing the strainer for. Anyways, a couple other details here, but I think it's probably worth skipping some of these things to get to near the end. I got a few details at the end here that I tacked on here. So yeah, mostly I wanted to point to those key points that I have at the end here. I got a couple key. It's kind of like a study guide, but key points to just review of what we've dealt with here. A built-up roof, BUR stands for built-up roof. That's like the tar and gravel or asphalt and gravel roof that are used exclusively on low-slope roofs. Ballast, that would be the gravel, the pea gravel that we put up on the roof. We call it ballast. In a submarine, we talk about the ballast. We adjust the weight by how we compress the air in air tanks and stuff, kind of like, and they call that a ballast tank. But the reality is, as they compress more air in there, we're adding more volume, and that can weigh things down. And then they can blow the tank when they need to go up. But here, it's the other way around. It's the gravel is the weight, it's the ballast, or the concrete paver. So sometimes when you got a penthouse up on top of a roof, they might have an area on that roof that they can walk out like a little backyard on the roof of a high-rise for the really wealthy. And they'll often end up with concrete pavers over top of the roof membrane to protect the wind uplift, just like the pea gravel, and it protect and shield the membrane from the ultraviolet rays. And then I want you to know EPDM, remember that, it stands for ethylene propylene diene monomer. And more importantly, what is EPDM? It's a synthetic rubber thermosetting material used in low slope roofing membranes. So you can remember that, you'll be fine on the test questions for the final exam on this. Couple of more points. The vapor retarders that we use are rated for their permeability or permeance in perm numbers, where the higher the perm number means more moisture can permeate the material. So a lower perm number makes a better vapor retarder. So model building codes define materials as vapor retarders if they have a perm rating less than 1. And so if they've got a perm rating higher than 1, that's not a good vapor retarder at all. So that's just a number to remember here. And here's an area divider. So this can be used like a vent in an inverted roof where the roofing membrane is on top of the insulation that's on top of the deck to vent. And the other thing that an area divider can do is accommodate movement. If you get a big enough roof area, normally we divide up the roof by firewalls. And so if that works out to be enough to divide up the roof, then you're not going to have stress cracks in the roofing material from changes in temperature and stuff. But if needed, you might have to vent, but also divide up the roof in smaller sections to keep the cracks from happening in the middle of that roofing material from changes in dimensions and size area. It's kind of like with concrete, every so many square feet you need, and so many dimensions, so many numbers of feet in different directions, you need to have control joints. And this is kind of allows you to have a control joint in the roofing material with an area divider. So that's what this is an area divider. You build a structure on the roof to divide it up. If you don't have it with firewalls. And then with the sheet metal, the last points are dealing with sheet metal. We have standing seams or flat seams, and I should rewrite this a little differently. I've got it listed like there's 3 seams. The batten seams are really the original standing seam, but there's a whole bunch of other kinds of standing seams. So yeah, batten seam is really just one type of standing seam. And then there's flat seams. So let me just show you some examples here. So when we have, you see all these seams on this page, they're sticking up in the air. And so they're all considered versions of standing seams. There's the overlap, there's a single lock, there's a double lock, and it's basically different sheets of sheet metal. You try to have the seam standing up in the air so that the water's not going to collect there where the seam is at, and that's how a standing seam works to keep the water out, is by standing up in the air, so the water's going to end up in the valley and it's not going to end up at the top of the peak, because it's not hanging around long enough for that. The original batten seam is a standing seam where they literally have a batten, a strip of wood in there. And so you literally can fasten on each side of these sheets to the batten and then put a metal cap over top of the whole thing that covers up the fasteners and the seams. And so the old-fashioned standing seam was the batten seam, and they're chunkier and a lot wider. Whereas a lot of these other versions, they might even have a machine that walks up that seam and bends it into that shape as it goes. It's already bent upward, and they can bend it down and crimp it into its shape with a machine that's literally rolling along the seam, grabbing and bending as it goes on the site. And then, whereas a flat seam is going to be bent down low and maybe even bent and flattened out low like this, but very often that would be the high side where this thing should be turned around 90 degrees, because the right-hand side of the page would be the high side, so the water can roll right over that seam. But more flat seams are done where they're soldered together. They're welded together with, but it's really called soldering, but it's a welding process of sorts. So I'll show you an example of that here. Actually, the best place for me to show you that will be when we're looking at, not sure if I've got it in here, or I might have it actually in the next presentation dealing with steep slope roofs, because there are cases where they'll join them that way too, but I'll see. Maybe I did put it in here. Okay, so looking at the drainage again, if you don't have proper drainage, you can have roofs collapse. And so there was a building downtown Baton Rouge called Club Theory. Not that I ever went there, so I have no experience, but I heard about it in the news when it collapsed, because they didn't have proper maintenance going on. So that was back in 2012. It's a while ago, but still, it was all from a big old rainstorm that happened on the night of September 30th, or maybe it was the night before. And if there were people in that building, it could have killed them, because this was like a, 5 or 6 story building, and the whole thing basically from floor to floor collapsed to the point where they had to tear that sucker down. We have buildings collapse from snow loads, and so roofs have to be made strong enough to support and prevent the building from collapsing with the record snowfalls you can get sometimes. Now, that's not going to happen in Baton Rouge. Here is a roof that was an inflatable roof, on a football stadium, the Minnesota Viking Stadium in Minnesota. But anyways, the whole thing was that normally if you had a high enough wind, it would have blow the snow off. They had too high of a wind for them to get up there and push the snow off and shovel the snow off. But it was too much wind for them to get on the roof to do that, but not enough wind to actually blow the snow off. So they were kind of in a sweet spot of problems. So that thing did collapse right there on December 12th of 2010. So there's an example. Interesting one. With that, we're done with this chapter on the half of the chapter 16a, dealing with low slope roofs. Next, we'll deal with steep slope roofs.